The last time we had a little quiz and everybody did it perfectly fine. So it's great that you, I hope, feel good about having the little quizzes every once in a while. So I guess that will be the plan. And some people even sent me their work later. That's fine. That's good that you are taking it seriously. So, I mean, the answer for quiz. So we will continue working with this sets, operations, so-called unions, intersections, and various other Venn diagrams. So just to refresh your memories on what we saw last time, I will maybe select one problem and do it. So ideas of union of the set, like an exercise part A will be taken everything covered by either set A or B. If you want to know the union of two sets, well, in this case, it looks very nice diagram, and you can list the set by using those braces, right? And put elements. Oops, this one doesn't want to go away, must should be traced. So if I try to list those elements, they will be such as a pi e, then square root of 2, square root of -1. You see, square root of -1. Yeah, they call it as imaginary letter I. It's a complex number. And there is some other things such as a e to the power of pi times I and 10 to the power of 100. So they just put some various elements in the sets and then 2 raised to the power of so-called aleph naught. So they just throw things out you. And one says, do I need to know what I is? It's a square root of -1. Do you have to remember it? No, they just give you various things such as 2 raised to the power of aleph naught. That's another thing that we don't worry about. And yes, we just can list those elements, whatever they are. We don't really try to get into this very deeply, I guess. So anyways, the union of two sets is one thing to realize. It's nicely provided by Venn diagram, or the intersection. Let's say if I look at part E of the exercise, well, then it'd be not as straightforward because we have a complement. So if I want to try to picture this complement of A or A prime, which is everything that is not in the set A, and this will be, looks like everything outside of A. So it looks like there's just elements in the lower corner here. But I say, oh, that's 3 6s. Well, whatever it is, the element. I say that, but there is a 4 Roman numeral. Well, I guess they trying to call it as a set number 4, and that's why I didn't really use 4. I say, what if I use it? Well, you can do it. That's fine with me. So as long as you do something that already makes me very happy. So if you do it, that's fine. Because it's questionable, is that the element 4 here or 666 and no 4? just like here we have elements sets 1, 2, and 3, as I understand. So they're naturally supposed to be there. It's just for your convenience, not for your confusion. But it's really confusing. But anyways, so what about intersecting it with a B? Well, the part that belongs to set B at the same time, as well as this highlighted in red portion. So it looks like this will be just this part, right? This part. That seems to have 3 elements only, so I highlighted it in green. So let me figure out what this green stands for. E to the power of pi I. It's actually negative I believe. Let me see what is going on. Well, you can put it in the calculator, I guess, but anyways. And then 2 raised to the power or 10 to the power of 100. So that'd be 1 and 100 zeros, right? Is that the number Google, or Google is a one with 1,000 zeros? I don't remember. But if you multiply 10 with 10, which is 10 squared, that's 100. And if you keep multiplying it by 10 again and again and again, that'd be multiplying it 100 times by 10. So that'd be a big number. That's why we better just write it with a power. Otherwise, it'll take you a while to put 100 digits there, and that's kind of waste of time. So that's why this is for the short operation. And then there's a aleph naught, there's a number. It's also a number that is cardinality of all integer numbers. So if you think of the set of naturals as well as integers, but we learn only naturals. So 1, 2, 3, 4, and so forth. So that was set of natural numbers. There are infinitely many of them. And turns out the number of elements here, when I say that's infinity, there is infinite. Yeah, we say that number is called aleph naught. It's like that with a little zero. I don't want to start getting deep into this cardinalities, but turns out there's a aleph 1 also, that's a cardinality of all numbers on the number line, and etc. And the 2 to the power is set of all subsets. So it turns out that this is 2 to the power of aleph naught is actually set of all subset of naturals, and that's aleph 1. And that's actually coming from set theory, but I don't think we need it, and I'm very surprised to see it here. So it's really taking a while to get to this when you take set theory class, but they just throw some things on you, and anyways, so you can see it and enjoy it. So anyways, the exercises that we do here again looks like it's something very familiar. So unions and intersection and not A or A complement is present here. So I can look at the next little group of exercises that actually keeps doing the same thing. So it keeps saying that or means union, or one or the other means union. And if you have intersection, it will be and. It will be common part and. So maybe I can clean this mess a little bit. Share it again. I guess there are various nice examples, but the ones that probably the most intuitive will be S or E union means or, and if you're looking at or means you have people that speak either Spanish or English. So someone may not speak English, but speak only Spanish, and someone may not speak Spanish, but speak only English. So that'd be here, but there is a group of people that speak both and Spanish and English, and that means overlap or intersection. And means intersection, so but I hope it is intuitive. So union means or, and intersection means and. I guess that's pretty much all this section is trying to tell us, and that's great. And I think the 2.3 is very interesting subsection that talks about the number of elements. So that's a little bit different because now we have a formula that will be produced in here. So if you don't just take a union, but if you're gonna look at the elements in that union. So what does that mean? Well, I guess I need to better get an example, and right away you will see what they're trying to discuss in here. Like, for example, I guess I need to get an example in order not to create any on my own. I probably better just go back to the problem that we just did. And what's the problem we just did? I think it's here. Neat. The one that I started with today. I should not have gone from that page. So anyways, here's our set. And notice that number of elements in the set A if I don't use 1, 2, 3, and 4, actually, maybe I should, right? Because why not? Maybe there's like 1, 2, and 3 elements. Yeah, let's do it. And when I say no, Alex, it's not 3, it's 3 more. Right? So that will be 6 elements. You say, why is that 6? Well, because set A is here. Right? It also contains the overlap with the set B. So that's the part that belongs to both. And now number of elements in a set B is going to be 1, 2, 3, 4 elements plus whatever we have in the overlap, right? And what we have in overlap, the same 3 elements, radical 2, radical -1, and capital, just a Roman numeral 2. So it's 7. And then what if I try to find the number of elements in a set A or, which is union B? You say, well, looks like there's going to be 3 of these and 3 more of those. Those are elements of set A. But then what I can do is add only 4 more. So it's going to be 7. And the main reason is that overlap A and B, the intersection, consists of only 3 little elements, right? The intersection I can also highlight here. The Venn diagram is so good, you can see right away whatever they're having in front of you. So you don't really need to think too hard, it's just pretty straightforward. But now, what if I try to produce the formula using these 2 n of A, or number of elements in a set A, which is 6. Okay. And a number of elements in a set B, which is 7. So how many elements should I actually have in their union? I say, Alex, if you count 3 and 3 is 6 and 4 is 10, but if you go with 6 and 7, it'd be 13. So should I take away that intersection 3, because if I used the entire set A, and then if I also use entire set B, I would utilize this overlap, that intersection, 2 times, one in A and the other from set B. And that's why we have a formula in that set of exercises that says if you take a union of sets A or B, then you need to add the elements of A and all elements of B, but you would be taking some set 2 times, and that set you taken 2 times, you need to subtract once, and then be intersection, right? Number of elements in the intersection. If you used it twice, then you need to throw one of them away. I say, why do you do that? You could just see the elements, 3 here, 3 here, and 4. So you don't really need those sets A, B. Well, sometimes you're not given this split that clearly, because it might be a very big set. Say 1,000 elements. So you don't want to list all the 1,000 elements, 1, 2, 3, all the way to 1,000. It takes a while. But if you have a formula which is always used for bigger sets, then you should be just fine. And that's why I want to take a look at the exercises for this. So let me see where I can actually, I think exercise set 2, 3. So I can try to practice this a little bit, this formula use, just to show you that this is really nice formula. Quite intuitive, but it's still something that deserves a little bit of attention. So Venn diagram. So here's the number of exercises. Okay, so let me look at the exercise set here, because it has number of elements in it. So I want to use some room now. So let me get this. So the formula I wrote above in red, I don't erase it. Let me see where it's here above. And let me try to find the answer for exercise number 83. 83 is where this whole thing starts. So why don't I just do 83? Now, for this exercise, you can do it anyway. You can use, or you may not use the formula intuitively. It is up to you. As long as you get done everything correctly, it's fine. So if I look again at exercise number 83, union of the 2 sets. So you can try to find the total number of elements by just, well, counting those elements, right? Because when they gave you those elements, it's nice, because that way you could just see them. Again, the formula is usually utilized when you cannot see the element. But here we have 1, 2, 3, 4, 5, 6 elements, and that's the total in set. You say, Alex, what do I need to use this formula? Why do I need it for? Well, you could actually see that with the formula, it's probably going to take you much longer, because then you need to know all the ingredients in that formula, such as number of elements A, number of elements B, as well as number of elements in the intersection, right? And then, of course, the answer is going to be the same because in mathematics, the answer is always the same. It's a perfect world. Because in real world situations, we know that sometimes the answer is no, but it may turn into yes, or yes, but not really, or whatever. So that's why it's not possible in mathematics. So anyways, if you look at the A, set A consists of three elements. There's a pound, dollar sign, and triangle. So say delta. Okay, three of them in A, and B has 2, 6, 4. This was words, as well as again the triangle. So that's 4. So if you also want to see what's in the overlap in A and B, where you know it's and, right? It's only one element. Well, and then you can use the formula. So you could also see that if you take 3 and 4, so what I'm doing is adding 3 with 4, number of elements in A, number of elements in B, and I have to also subtract whatever is in their intersection. Of course, I will get the exact same answer, which is 6. So which way you have to do it? Well, up to you. As long as you do it, it's already perfect. Because whenever you are doing the exercises, that's already great, right? So I guess that's the point of story. So I guess I'm gonna do another one. How about 87? And of course, I don't want to use the formula. I'd rather just use the number of elements. And in order to be able to use the number of elements, I need to see what set they're talking about here. And this is an intersection. So I have to find the intersection of sets A and B. And that's my favorite part. It's here, that triangle. That's intersection, right? But then I have to see what is not in the intersection because we're really looking for the complement or not the intersection. You see that? A intersection, not the complement, which is on the outside. So you have to look at what's not in the intersection. So everything that is not in the intersection, I'm going to have to now count. And I need not to worry about U because that's for the universal set, and neither A nor B because those names of the sets. So what I do is I just look at the elements and see how many of them will be present in the highlighted region. It looks like 2 from here, right? I can write it down so I don't get mixed up. And looks like 3 more here. Do you see any more? 2 more, right? 10 and 0, 1. 2. So it looks like whatever it comes out, 7 is the answer. Well, one may start wondering what for do we need all that? Well, it's good to realize the number of elements in the intersection. In fact, what I plan is to give you a little midterm exam. It's not going to be a big, it's going to be a little smaller than the pretest. Remember, pretest took you the whole page. It will be small, but it'd be in the middle of semester. We're at the week 4, so 4 more weeks, week 8. I was trying to schedule it for Monday, week 8 will be the midterm. And I plan to give you one of the exercises on it that will look pretty much the same as what we just did here. So like 83 or 87. It's not hard, right? But it's worth to make a note for yourself and realize that that's what you need for the exam. And of course, I will remind you of that when we get closer to that date. So we'll discuss, of course, the midterm in very detail, so you don't need to worry. But
Can I
that's
ask something, Professor?
it's
Are we going to do some assignments before midterm or anything like that?
homework, right?
Yeah.
Yeah, so the three problems from each lecture, you can just copy. For example, you can copy 83, 87, and
Oh,
whatever.
so we choose by ourselves? I mean, because I've never done any assignments in this class.
Oh, that's not a problem. You just need to get a piece of paper and check out your email with lecture recordings. I'm also recording this particular lecture.
Uh-huh.
And the previous recordings, you can just do three problems from each of those. The same problems. It's fine.
O- Okay.
They just copy them. Some people just copy them, but I want you to maybe think about it. I guess that'd be a good idea because when you
Okay.
try to
Okay.
do it yourself, then you may not do it right, but it's good to look at how it's done.
Okay.
I hopefully correct.
Good that I asked because I was wondering
Yes.
why we never have any like assignments or homework to do. So I was waiting, you
Oh,
know.
yeah, you shall, but you don't want to turn it in as of yet when the
Oh,
midterm
we don't have to
comes.
turn them in.
Not right now, not right now, not today or tomorrow. When the midterm is coming, the midterm day, which is in 4 weeks, I will ask you, I will remind you, don't worry, I will tell you, please email me your homework. And this
Okay.
homework, you should email me in the same day, because if you email me one problem today, two tomorrow, and three, and how do I keep track of whoever is done and what? So it's going to be quite challenging for me. And
Okay. So you mean for each class that you recorded that we choose any examples,
yeah,
two or three, and to redo them again.
yeah, exactly,
Okay.
exactly. That'd
Sounds
be your
good.
homework. Homework.
Okay. Okay.
But
Got it.
also, in addition to it, we will have a little quiz maybe today, a little later at the end. And for the quiz, we'll just put the answer in the chat, like
Okay.
we did on Wednesday. So that's another type of assignment that you can do right away, which is most people did right away on Wednesday. But somebody decided to send it to me a little later, and that was also fine. I check my emails and I acknowledge. I always say thank you, and that way I know, and you know that I received. So yes, so that's little by little we're getting more and more stuff, and I guess that's what we do for this class. So that's very good that you clarified that because I'm sure if you had that question, then some other students in class also appreciate it because they probably also felt it.
Yeah, I was aware of the little quiz and I know that we're gonna have that in class, but I was waiting to have like regular assignments or homeworks to do at home and to practice with more exercises. But I think this is the third or fourth class that we have recorded, and I was still waiting for like something like that. So
Well, if you want, I can overload you with homework. If you really want, I can have you buy some Excel versions of test banks, and you will be doing it, we'll all load it with those tests and doing the same thing again and again and again and again and again. But what for? It's the same thing.
mm-hmm.
That's why, what else can I possibly ask you? Just set and compliment, and I think that's good
No,
enough.
I think your way, like choosing from the recording class, I think is more convenient and more easier.
Yeah, that's all. My goal is not to make this class complicated. In fact, my goal is to give everybody a perfect grade on this class, and I am serious about it. And I hope you start to see it. And I guess that's how we usually go about this story. So everybody enjoys it. That's the point. So, anyways, let's do some more stuff here. And I'm waiting for your other questions. If you have any other questions, please ask, because I want to abandon this story, because turns out they start to put more sets and they doing the same thing and more, and I guess we got everything we need at this stage, really. And now I want to move to the next chapter. I want to start with the next chapter, or maybe I'll start it next time. Maybe I'll start it with it next time, because I think it may be a little bit overwhelming, right? For one time. Maybe we will do a couple of more exercises. I totally forgot. And I can give you a little quiz, and then we'll leave the next chapter for next time, because we're in a good, I guess, shape for covering material. So anyways, let me try some more exercises here, and then I'll have you also try one for practice. So how about if I try another exercise in this nice little group? I just want to clean this mess. Stop sharing and share it again. I think I'll be asking you to do the exercise number 86 for the quiz. And to show you how I would recommend you to do it, I will do exercise 85. So, as I promised, quizzes are very reasonable. I do the exercise on my own and then ask you to do very similar exercise. Like if I try 85 right now, that says, how about if you find a complement? So all elements that are not in the set A. So what's not in the set A? Well, looks like whatever's on the outside or not in A will be in the complement. Please notice there is a couple of more elements patiently waiting for us in here, right? So what's not in A? Well, looks like 2, 6, 4, and then two more, total of 5 elements will be not in A complement. So I think that way it'd be a good idea that you try for today's quiz what's not in B. And just like you did last time, put your answer in the chat, in the Zoom chat. And that'd be all we need, because I want to, I guess, end this story, the story for this particular chapter today. So I think it'd be a good moment to give you a little break, right? So quiz again is, please write the number of elements that there's not in B. Maybe I will get rid of this stuff that I wrote, because that may not be convenient to some people. So do problem 86, that'll be our quiz for today. And then put the answer in the chat, only please to send it to my name, and then you will be done and deserve to have a good little time off till Wednesday, right? So thank you for being here. Two people already sent me their answers, and
Is it correct?
I'm not sure, because one, the answer is correct, the other is not. So maybe if you're not going to hurry, because you have plenty of time, so just think about it. So what is not in a set B? What is not in the set B? And again, check out 85. I did 85 just now, right? So it's very, very similar. But again, you can think about it. You can always send me your answer or correction to your answer later, right? So just think, take your time, and put the answer in uh, the chat. Oh yeah, that's great. That's great.
Is that one correct?
Yes, yes, that's good. So anyways, if you're done, feel free to relax.
We can go?
Yes. Enjoy the rest of the day.
Okay, thank you, Professor.
So,
Have a good
see you
one.
next time. Bye-bye. Don't hurry. Don't hurry. Take your time. You don't have a time limit on this. Stop to record.